All right, taking a look at problem 5. It says that a 50 kilogram cart is moving across a frictionless floor at 2 meters per second. 70 kilogram boy riding the cart is going to jump off so that he hits the floor with 0 velocity. So here, let's start with a sketch. So let's see. We're going to have this problem 5. Okay, so we're going to have that cart, right? So I'm drawing like a shopping cart, maybe, right? Yeah. And let's see here. That's our before picture, and our after picture. Yeah. Now, you say the cart starts off moving to the right at 2 meters per second. So this is 50 kilograms. All right. And the boy's going to jump off in such a way that he was moving at 2 meters per second with the cart, but he's going to end up stopped. So which way does he have to jump for that to happen? And you say, well, he was moving to the right. He's going to have to kind of jump left, right, to make it so that he stops. So he's going to kind of jump off. Don't ask exactly how, all right? He's going to have to kind of jump off this way, yeah? Yeah. So he's going to kind of jump off that way. So we'll end up kind of landing here, kind of stop there, right? So at the end, we want him to have a speed of 0, right? And we're going to be asked, let's see here, his mass is 70 kilograms. And they want to know, what's the change in momentum that the boy gave to the cart? So how much did the cart's momentum change by? And then what was the velocity of the cart after the boy jumped? So we're going to try to find, in part B, we're going to try to find this velocity of the cart at the end, that final velocity of the cart, right? And we want to know the change in the momentum of the cart is the other thing we're trying to find, okay? So take a look at this. You say, well, we're going to do a momentum calculation, right? A conservation momentum. You say, what do we want to make our system here? Okay, and you say, well, we want to find the change in momentum of the cart, so clearly we need the cart. And you say, do we want to include the boy or not? Well, is there going to be an impulse acting on the cart? And you're like, well, yeah, the boy's going to push off the cart. And so I don't know the force of the boy. I don't know the duration of the push. I don't have any good way of calculating that impulse. So I need to do a combined system so I don't have an outside impulse. So my system is going to have to be the cart and the boy. So that then when I go to do F delta T is delta P, the big formula for this unit, the impulse momentum formula, they say I'm not going to have an outside impulse. The only forces acting on my system here, outside forces now on that combined system, would be gravity and a normal force from the ground. Those forces, they're going to balance out. So the total will be 0, right? The other thing is, those forces are up and down, but we're interested in the sideways momentum. And those vertical forces don't affect the sideways momentum. Each axis we can look at independently. So this is going to be 0. And so here, my system is both cart and boy. I'm going to have the change in momentum of the cart and the change in momentum of the boy. Yeah. So I got them both. And so you say, all right, this is the thing I am trying to solve for. So you say, well, do I know the change in momentum of the boy? You're like, well, you say, yeah, actually, I can solve for this part. And then that will be equal, but I got to add to 0, equal but opposite to the change in momentum of the cart. So this is going to be fun. This is going to be fun. So if I do this, I'm going to have 0 is change in momentum of the cart, which is what I'm trying to find. Change in momentum of the boy, that would be momentum of the boy at the end minus momentum of the boy at the start. Actually, these are lowercase p's. And you say, okay, momentum, that's going to be mass times velocity. So this will be mass of the boy, velocity of the boy at the end, minus mass of the boy, velocity of the boy at the start. And we said, hey, wait a minute. At the end, the boy is stopped. So actually, this term drops out. That final momentum is going to be 0, because velocity at the end is 0, right? So I really just have the momentum of the cart, the change in momentum of the cart. They say it's actually going to be, I'm taking away the momentum of the boy to the right. Yeah, he had momentum, he was going to the right, but we're going to stop him. The momentum gets transferred to the cart. So that's really just going to be mass of the boy, velocity of the boy, rearranging, moving that to the other side. I'd be like, mass of the boy, velocity of the boy at the start would be equal to the change in momentum, delta P, of the cart. Okay, change the mass of the boy, velocity. You say, hey, that's going to be what? That's 70 times the initial velocity of 2. Okay, and so I'm going to get a positive 140 kilogram meters per second. That's how much was given to the cart, right? That's the momentum that the boy lost, that's the momentum the cart gained. All right, so that's part A. Okay, part B, all right? Part B, we want to find that final velocity. And so you say, okay, well, since I know the change in momentum of the cart was a positive 140, we can just go ahead and expand out now that change in momentum of the cart and get to a point where we have that velocity in there. So the change in momentum of the cart, which we now know is 140 kilogram meters per second, isn't that the momentum of the cart at the end minus the momentum of the cart at the start? The momentum of the cart at the end, that's going to be mass of the cart, velocity of the cart at the end, which is what we're trying to find, minus mass of the cart, velocity of the cart at the start. And so you say, yeah, change in momentum of the cart, we know that's a positive 140. Mass of the cart is 50. The final velocity of the cart, that is what we're trying to find, minus mass of the cart times the initial velocity of the cart. So you say, yeah, hey, when I do this, that's 100, move to the other side, I'll be adding 100, that'll be 240 divided by 50. 240 divided by 50, that's like 24 divided by 5, which is, right, 240, right? Yeah. That's going to be 4.8 meters per second is that final velocity of the cart. Okay, that's part B. All right. Okay, so that's problem 5.